Good morning, students. Today we again discuss about some remaining parts of flexible computations in imprecise periodic task model. As we know, the periodic task consists of four tuples: phase, period, execution time, and deadline. So this is just notation of these tasks, optional and mandatory tasks associated with these four tuples. Each task to RITI, CITI is an end-to-end chain of two periodic tasks, and mandatory as well as optional we have represented by these notations by M and O. The ratios execution time P upon PI is called the utilization, and EM upon PM are the utilization for mandatory tasks. The total mandatory utilization of the system is the sum of mandatory utilizations of all the tasks in the system. Monotone task means we have discussed yesterday too. A task is monotone if its optional component can be terminated anytime and the quality of the result produced by the job does not decrease as its optional component executes longer. A monotone task is based on incremental algorithm whose result converges monotonically to the desired result with increasing run-is time. Suitable for application requiring heuristic search, statistical estimation and prediction, incremental information gathering and database queries. Maximum flexibility in scheduling, as we can dynamically decide which optional component to schedule and discard those optional components anytime. Imprecise task with 0-1 constraint. Its name suggests either 0 or either 1. Means either we discard the jobs or either will execute fully all the jobs. Typically, there is no benefit by completing a sieve in part. We want to either execute a sieve to completion or discard it. An imprecise task with 0-1 constraint requires the optional part to be either fully executed or not at all. Scheduling job is the same as scheduling two version jobs. One version contains mandatory component plus optional component. Second version contains only mandatory component. Either primary version is scheduled or discarded entirely corresponding to alternate version being scheduled. Okay, what primary version say? Either will execute optional plus mandatory or either will execute the mandatory task only. So implementation method: high scheduling overhead due to complex algorithm implemented by using multiple versions of task. Precise version, as we discussed, precise version means will execute both. Alternate version that includes only mandatory part, not optional. Shorter processing time but imprecise result. What will be the benefit if we'll consider only precise result? If we'll consider only precise, that accuracy will be there. But if we'll consider only mandatory part, then the processing time will be small but result will be not so accurate. Dependent flexible jobs model. This is a model in which we are assuming that previously referred jobs is that quality of the result produced by a flexible job depend only on the amount of resource allocated to the job. This assumption is wrong when jobs are dependent. What we are, how we'll show the dependency in real-time systems? Through the task graph. For that precedence graph, there are predecessors and successors. Similarly, if the result produced by a predecessor is imprecise, a successor job may need to execute longer to compensate for the degradation in input quality. So this is the dependent flexibility. How will implement? The execution time of both the mandatory and optional components of a successor job depends on the result quality of the predecessor. Each job has a mandatory extension and an optional extension which model the extra work the job must do for a poorer input. The job is a chain containing its mandatory component followed by its mandatory extensions, which is in turn followed by optional component and optional extension. When input is precise, the execution time of both the extensions is zero because we not need any kind of extensions to recover the poor quality. So the execution time of both extensions are non-increasing function of the quality of the job's input. This significantly complicates the scheduling problem, for which till date no simple to implement and well-performing algorithm has been found. What are the criteria for optimality? There are two objectives. First objective is that our schedule should be optimal, and another one is the quality will take care. So objective 1 is the same as those for all classical hard real-time scheduling algorithm, that task should complete by its deadline. To ensure that each task job will produce an acceptable result on time, meaning that all mandatory jobs complete by their deadlines. This is our optimality criteria of 1. In other words, we can say that feasible schedule whenever there exists one for the task set. Objective 2 is to minimize the result quality of each flexible application by scheduling as much as possible optional jobs in the applications. Errors and rewards. Quality of result of a flexible job is typically measured in terms of the error in the result or reward attained by the job. Error in the result is the distance between the result and desired precise result based on the domain specific measuring through by the application developer. We have assumptions that all mandatory jobs are completed on time. System has capability to do admission control and hard real-time scheduling. Thus, result produced by all the jobs are acceptable in absence of timing failure. Error is maximum when the optional part is discarded entirely. Let maximum equals to 1. Let eta x be the error in the result when x amount of processor time is allocated to the optional component. Eta equal to 1 and another one is 0 when we are considering the execution of optional jobs, where E0 is the execution time of optional component. For 0-1 constraints jobs, these two error value completely categorize the behavior of its result quality. The error we want the error should be 0. How we can categorize general error functions is E, sigma and I. Sigma is actual optional component processor time for task I, and I is the error in input of task due to predecessor imprecise result. So execution time and the error is given as an input. A task may need to do extra work to correct its input error EI, and a poorer input may slow down the rate at which its result coverage to precise. Both mandatory and optional executions are non-decreasing function of error. Optional error may become infinite if EI becomes larger than some threshold. Thus, the task I may never produce a precise result no matter long it's execute. A reasonable error function neglects input error, or error is defined by simply execution of optional jobs minus sigma 1. For a given schedule, the total error of the task set is multiplied by the weights. Eta is equivalent to summation of I equal to 1 to n Wi ei, where Wi greater than 0 are weights of the task. E0 is the optional component, execution time. Error in the result of monotone jobs typically decrease in discrete steps. So this is the formula for this. Optimal algorithms refer to an algorithm that finds a schedule that is feasible and minimizes the error function. Error function means the total error. An optimal scheduling algorithm always finds an optimal schedule whenever a feasible schedule of task set exists. Next, we will discuss about these imprecise scheduling algorithms. Thank you. Have a good day.